Hello everybody, today we are going to discuss L'Hopital rule to evaluate a limit of a function. Here we have the indeterminate form, just to remind you. L'Hopital rule, it's a very important rule. We can find limit of a function f of x over g of x using a new concept, as we can find derivative above and derivative below. So limit f of x of g of x when x approaches c equals limit f prime of x over g prime of x when x approaches to c. And then you can use the direct substitution to find the final result of your problem. For example, here we have a problem x squared plus x minus 12 over x squared minus 9, and we have to evaluate this limit when x approaches 3. If you try to use the direct substitution, you can find the answer 0 over 0. It doesn't make any sense, so you have to use L'Hopital rule, or you can use the factorization as we talked before in previous lecture. You can factorize above here, x squared plus x minus 12, it will be x minus 3 over x plus 4, x squared minus 9, which is x minus 3 times x plus 3. You can delete the 0 factor, you can cancel x minus 3 with x minus 3, so after simplifying this fraction you have limit x plus 4 over x plus 3 when x approaches 3. You can use now the direct substitution. This is the old style of the solution. And now you can solve the same problem using L'Hopital rule. You can find derivative of the function above and derivative of the function below. So x squared, its derivative is 2x, derivative x, it will be 1, derivative 12 is 0 because it is a constant. And now x squared, its derivative is 2x, and 9, its derivative 0. Now you can use the direct substitution, and it implies to 7 over 6. Here we have another problem. X minus pi over 2 by 10x. We wanted to find the limit of this product when x approaches to pi over 2. L'Hopital rule works only with fractions, so we have to construct our own fraction here. You can rewrite your problem again as x minus pi over 2, and we know that 10x is 1 over cot10x, so you can put it down here in the denominator. So we have a fraction here. Now you can apply L'Hopital rule. You can find derivative above and derivative below. So the final answer is 1 above, because derivative of x is 1, derivative pi over 2 is 0. And now cot10 x, its derivative is negative cos x squared. After direct substitution with x equals pi over 2, the final answer is negative 1. Another example. Find the limit e power 2x minus 1 over x when x approaches 0. If you try to use the direct substitution here, the final answer is 0 over 0. It doesn't make any sense, so you have to use L'Hopital rule. L'Hopital rule, you can find derivative above, which is 2 e power 2x, because derivative e power 2x is e power 2x times the derivative of the power, derivative of negative 1, 0, and derivative of the x below is 1. Now substitute x equals 0, and the final answer is 2. Another example. Find limit ln x over x when x approaches 0. If you try the direct substitution, the final is infinity over infinity. It doesn't make any sense, so you have to use L'Hopital rule. Find the derivative of the function above, which is ln x. Ln x, its derivative is 1 over x, and derivative x, which is 1 down. Now substitute. You can use the direct substitution when x approaches infinity. Here 1 over infinity equals 0, so the final answer is 0. Another example. Limit x squared over e to the power negative x when x approaches negative pi. If you use the direct substitution, you can find here the answer is pi over pi. So you have to use L'Hopital rule. L'Hopital rule, derivative of x squared, derivative above, which is 2x, derivative of e power negative 2x, derivative of e power negative x is negative e power negative x, because e power negative x, its derivative is e power negative x times the derivative of the power, which is negative 1. If you try to use the direct substitution here, you can find indeterminate form again, negative infinity over negative infinity. So you have to apply L'Hopital rule one more time. So derivative of 2x is 2, and derivative of negative e power negative x is e power negative x. Now substitute x approaches negative infinity, so you have 2 over infinity, which is 0. Another example, you have here limit e power negative x root x when x approaches infinity. And now to find the limit of this problem, first of all, we have to rewrite our problem in the form of a fraction to use L'Hopital rule. Here, e power negative x, it can be written down as e power x. You can change the sign of the power and write it in the denominator down. And now if you try to use the direct substitution, it will be infinity over infinity. So we have to use L'Hopital rule here. Derivative of root x, which is root x, it means x to the power half, so its derivative is half x power negative half. Derivative e power x is the same, e power x. And now if you use the direct substitution, you can find the answer 0. And this is your final answer. Another problem. Here we have limit. Suppose y equals the limit of 1 plus 1 over x to the power x when x approaches infinity. So to make this power down here, we have to apply len for both sides. Len y equals the len of this limit. And now you can interchange between len and the limit. So your problem will be limit len 1 plus 1 over x to the power x, and you can put this power behind the len here. So this is our form limit when x approaches infinity of x len 1 plus 1 over x. The power x here, it comes down behind len. Now you can use L'Hopital rule, but L'Hopital rule needs a fraction. You can write this x as in the denominator as x to the power negative 1 or 1 over x. So we have len 1 plus 1 over x over 1 over x. Now find derivative below and derivative above. Derivative of len 1 plus 1 over x is 1 over 1 plus 1 over x times the derivative what inside. Derivative 1 is 0, and the derivative 1 over x, or let me say x power negative 1, its derivative is negative x power negative 2, or you can write it as negative 1 over x squared. So derivative 1 over x is negative 1 over x squared. And now down, derivative 1 over x is negative 1 over x squared. Now you can simplify here this negative 1 over x squared with negative 1 over x squared. Here you can cancel them. So you can use the direct substitution in the final answer. You can find 1 over 1 plus 1 over infinity equals 0. So the final answer is 1. This is y. This is y. This is len y. And we need to find y. So len y equals 1. If len y equals 1, so y itself is e. So the final answer of this problem is e. Another example. Here we have limit when x approaches 1, or 1 over, or from the positive side, 1 over len x minus 1 over x minus 1. You can find a common denominator here. So len x times x minus 1, and cross multiplication 1 times x minus 1, and negative 1 times len x. If you try the direct substitution, you can find 0 over 0, so it doesn't make any sense. You have to apply L'Hopital rule. Find the derivative above. Derivative of x is 1, derivative 1, 0, derivative negative len x is negative 1 over x. Here we have a product. You have to apply the product rule. Derivative of ln x first times the derivative of the second, which is 1 over x, plus second times the derivative of the first, which is 1. Now we have limit. Here you can simplify this problem and you can use the direct substitution here. If you use the direct substitution, you can find the result is 1 minus 1, which is 0. Above and below, we have 1 minus 1 plus x times ln 1, which is 0. So you have 0 over 0. So again here, if you multiply by x above and multiply by x below to simplify your problem, the final answer is x minus 1 over x minus 1 plus x ln x. And now find, using the direct substitution, it will be 0 over 0, so we must use L'Hopital rule one more time. So derivative of x minus 1, which is 1, and here derivative of the denominator is 1 plus x times 1 over x plus ln x, because here we have derivative of x minus 1 is 1, derivative x ln x, it is a product, first x times derivative of the second, x times 1 over x, plus derivative of the first, which is 1, times ln x. Use the direct substitution here and the final answer is half. Another problem here. Here we have limit 1 over sine x minus 1 over x. If you try to use the direct substitution, you can find infinity minus infinity. It doesn't make any sense, so we have to apply L'Hopital rule. But before applying L'Hopital rule, we have to find a common denominator here. So we have the common denominator, x times sine x, and cross multiplication 1 by x is x, negative 1 by sine x is negative sine x. Now you can apply L'Hopital rule. Derivative of above x is 1, sine x is cosine x. Derivative below, you have a product, so you have to apply the product rule. Derivative of the first is 1 and multiply by the second. First x times the derivative of the second, which is cosine x. Now substitute x equals 0 here, so 1 minus cosine 0. Cosine 0 equal 1, so 1 minus 1 is 0, and if you substitute below x equals 0, the final answer is also 0. So we have to apply L'Hopital rule one more time. Derivative of 1, 0, derivative of cosine x is negative sine x, so we have negative cancel, so we have sine x over derivative sine x is cosine x. Here we have x cosine x, derivative of the first is 1 times second, plus first times the derivative of the second, which is negative sine. Now use the direct substitution, the final answer is 0. Another example here. If you have x to the power x and you have to find limit this function x to the power x when x approaches 0 from the positive side, you can assume that y equals limit x to the power x when x approaches to 0 from the positive side, and now apply len to get this power down behind the len. Also, after applying len, you can interchange between len and limit, so you can write your problem as limit len instead of len limit. Now put the power down behind the len, so you have limit x ln x. And x ln x, the direct substitution implies two indeterminate form, so you have to construct a fraction to enable L'Hopital rule to work. Now we have ln x. This x can be written down as 1 over x, or x to the power negative 1. Now find the derivative above and derivative below. Derivative of ln x is 1 over x. Derivative 1 over x is negative 1 over x squared, as you can see here. Now if you use the direct substitution here, 1 over 0, you can simplify before going through the direct substitution. So you have this x can be cancelled with x from below. So you have the final answer is negative here, negative x, and sorry, so you have here a limit of negative x if you substitute x equals 0, so len y equals 0, and in this case len y equals 0, so y equals 1. So our final answer is 1.